not sure they are really online.
Okay. One should be online. We are proceeding with our last presentation, so
Yeah.
don't get.
I will be keep it short. I know it's been a long day. I'm not sure you will follow me, but it's something different, so maybe it can attract your curiosity. It's another application developed in Almira. And I'm Barbara Cantalupo from the University of Torino. Obviously, I'm not the only one that worked on this, and I will show you the team in the end. As I was saying, this is an application specifically divided internally in Almira. And the idea was making something, a kind of framework that we can use for developing, and executing applications for using the software heritage dataset. So we want to provide an environment tailored for this kind of dataset. And why we want to do this? The source code, you all know that, what is the source code. You know that you can use it, modifying, and use it for other components. And it has a license that allow you to use it in a legally available way. And the nice thing about the open source code that is 90% of the code that is used actually. I really didn't know before starting to this project. I didn't know this. It's very interesting, and also it's interesting that European Commission estimate that there is a saving in costs of about development, 114 billion per year just for development costs. So it's I think that focusing on open source is quite an interesting thing. And we have this initiative that is software heritage. It started in 2016. And their mission is to collect, preserve, and share the code, a kind of, heritage for the future, preserving all the source code that is available. And what they do, they collect they collect the information, source code from different repository, from GitHub and any other and a lot of other kind of repository where source code data is available, and then store it, making this building this Merkle DAG. Merkle is a cryptographic DAG in the sense that they define a unique identifier for each node that is calculated according to the content of the node, and in this case also according to the content of the children node. The problem is that it's a very huge data set. It's now it's reaching 1 petabyte, and also it has a lot of metadata. So if you want, it's nice because you can traverse it. You can make query asking for project. But if you want to use it for typical AI application or MapReduce where you need streaming or you need to ask frequently about the code that is not performing because you need to traverse the DAG and it's not performing. That's why we thought about this framework. That is, so we are making a framework where the application can develop its own application. We have the framework where the application is running, and specifically it's built on top of an ad hoc storage that could be a distributed file system, or it can be GeckoFS or Acules. So we exploit the benefit of the storage, and then we can make query on software heritage. Obviously, we try to make it performant. How? Using a cache. That is quite typical, but we will see how. The framework is built on usual layer framework. We have the application layer that is interfacing the user, data orchestration layer that is interfacing software heritage, and then we have the storage layer where the cache is built and it interfaces the ad hoc storage. The framework, the two-level, the orchestration framework is built on top of Spark Streaming, just to, to exploit the streaming capability of Spark. So starting from the bottom part, we have the storage level. It's where we build this cache mire, the cache on mire, we can say, that is a kind of a project cache, a key value, distributed key value storage, and the key is the project ID, the one is storage in Software Heritage, and the value is project source code. By the way, if you query Software Heritage, it will provide you with the target Z of the code that you are asking for. Our cache has the usual, the usual APIs such put, get, and other one have been added, like removing for cleaning purposes. But we also have an algorithm to clean the cache. That is the least recently used algorithm for the cache, and we have obviously a script that is launched at some interval to be sure that the cache is maintained under a kind of threshold. Obviously, if you want to use a cache, it must be dynamic. It should scale. So we have dynamic scaling, workflow balancing. How? Just launching additional cache instances in different nodes when it is needed. And as I say, the storage infrastructure is on top of ad hoc store, some kind of ad hoc storage. So the combination of the balancing of the cache and the ad hoc and the ad hoc storage performance can provide a lot of augmented efficiency of the application that is running on top of this framework. The orchestration layer, as I told you, is basically exploit the Spark streaming advantages. It means that when you submit the application, a pool of data stream generator, the application controller is generated, and the application controller are the one that create the stream, in the sense that they will query the cache if the content that you're looking for is available. He will return you in a streaming form, while otherwise it will interrogate the Software Heritage. Obviously, in this case, we are using the usual, Software Heritage API. By the way, you can have an app controller can spawn different application instances in different nodes. So it's a distributed application that is controlled by the app controller that is streaming the data. So we can use the workload balancing. As I said, there is the application management level. So it means that a user can build his own application. Currently, it's a Scala application because we are using a Spark Stream. And he provides the jar of the application and the recipe. The recipe means the kind of project that is want to use want to query and work on from Software Heritage. Not just one, obviously. The kind of the identify of the project that you want to apply the application on. Obviously, we can have the same recipe for different application, or we can use one application with different recipe. They are not connected. They are not connected, So you can have your application and make query on different type of recipe. By the way, they are called recipe because in the jargon of Software Heritage, they call cooked the content that is provided to you, in the sense that you are making a query, they cook your query and provide you the target Z containing the source code. Just to make, to show how this works, we also developed an application in the framework that is a license checker analytic app. What it means, it will work on the querying about finding something about the license. It's quite late, so I'm not bothering you with the important value of the licensing, because sometimes when you mix different license, it can also happen that you have some court case. It could be a real legal problem. So there are a lot of people that are working on understanding and evaluating different licenses in source code. If you are interested, we will publish a paper soon. I hope I don't see Raffaele, because this was presented at Itadata, so the result of this application. It's quite interesting because it talks a lot about the kind of license. GPL is one of the most more restrictive, and the one that will generate some problem. We will see. As I said, I'm not. This is the kind of a matrix showing the different kind of matrix. License starting from the really permissive to the proprietary one. A very different kind. And another amazing thing is that there are 2,174 kind of license. So you can imagine that that merging a different piece of code with different license, obviously they will have just a little bit, differences, but it can cause legal problem too. Our application. So what was the idea of the application we developed? Find identifiable pattern in the appearance of the license. So the question is, there is a pattern when there is the conflict in the license, and it has also an impact. It also depends on programming language, on application domain of the code that we are investigating. The application is a pipeline. I show you how it is the framework, and as I told, this is the application level. Well, the user define the recipe that you want to provide to the framework, and in our so you need to choose which project you are interested in. In our case, we selected the top 100 most started project, the top 100 most supported project, the top 100 most started project for each of these kind of languages, because I told you that you want to see if there is a correlation between conflicting license and languages. Obviously, not all these one were available in software editing. That's why we have this strange number, 835. The second step, we are going toward the orchestration level. So the application, what is doing the application? We need to search for. We will have this. We'll have this project from the software heritage. We will look for the explicit license, or maybe not, maybe in code, because the license could be in the header in a different file. So we need to search for it, and we did it using ScanCode. That is the most famous application for doing this kind of stuff. Then we looked for this license, and then we apply. As I was saying. We have different kind of, mismatches, inconsistency. They are not all equal, I can say, because you can have just two different licenses, but they can be, it could be not a problem. You can have mismatches, so it's different, and you know how to merge it, but it's still not a problem. Or you can have conflicts, so maybe you have a permissive license, and then you use this code for something more restrictive, no problem, but the other way could cause some problems. So conflicts are something special. And there is this open source license checklist project that provides a matrix where we can that we can use to check if the license that we have found in the previous step are in conflict or not. You know, the analysis, we have all the value of the analysis that we provided, but it's quite long. So I can tell you in just 1 minute that we could demonstrate, we could obtain that there is a correlation between the project complexity and the number of licenses. I'm sure you can tell it's quite obvious, because the more file you have, the more probability that you have conflict in license it's available. And as I was saying at the beginning, the biggest problem is usually with GPL that is more restrictive. So combining the copyleft license is quite complex. What copyleft is, we have a weak, strong copyleft in the sense that you can use it and you are forced to maintain the same license, or you can use it if you modify, you maintain the license, but if you put it in another code, you can have a different licenses. So as I was saying before, it's a very complex word, the word of license. But we have this result. And if you're interested, we have the number of the result, how GPL is in conflict with other, and there is a lot of stuff. Also interesting, maybe more interesting, if you are curious about the number, is the correlation with programming languages that is not shown here, but the programming languages where the conflict are, where there are more conflict are C, C++, and Go. Maybe we are not sure about what is the meaning of this, because it could depend on the people that are using if they are more used to use license, or we are not sure what is the reason for this. And then also for application domain, the domain that is, domain, we classify some domain like mobile, IoT, web, DevOps, and development tool framework, different kind of framework, application domain. And DevOps is the one that is showing more conflict. In this case, the reason could be that it's using a lot of different components, so merging a lot of components cause merging a lot of licenses, so the conflict arises. Going back to the original part, because we in Antmai, we are interested not more in the application that we can develop, but how the framework works. So we tested the application using the framework, obviously, on the usual HVC for AI that is used for Antmai. And in the case of the 70%, 100% cache hit, so we have everything in the cache, so it's just an overhead of the application. In this time, we can see that the application scale well, not for a large number of nodes, but until the 8-10 node it can scale. More interesting is quite obvious, but more interesting in our case is the cache impact that we have using software heritage, because we have two different kind of cache, in the sense that the cache, the implementation is CacheMire, but it is a project cache, the software heritage project that we have in cache or application level, in the sense that if you are using the scan code to check the application, you obviously will provide a JSON file with the code that you already computed. We also can keep it in the cache, so we have different kind of cache. And this is a log scale, so you can see that in this case, if you have all in cache, you have 158 second time, while if you need to search and work on software heritage, you will have 17,000 and some more. So it's a very huge impact on the cache. So I think that if you want to really use it for AI or for streaming, I think it's very good. So that's all. I promise to be short, and also I promise to show you the teams from different institutions. We also have the code available. I will put it in the Admire GitHub before Jesus will ask. But I think I hope you are curious about all this stuff. I was, so if you are interested, you can ask me, and I will forward to the other people on the team if needed.
Okay.
And that's all. And maybe this is the end.
Thank you, Doctor. One question for the results. You told us you have been integrated with Hercules. Do you have numbers for that?
No, not yet. Yes, this is, sorry, this, I don't know if it's, no, it is from last year.
Yeah.
I'm sorry, I missed to say it. But
Yeah,
it's
we are very interested
Yeah.
in the numbers.
Yeah, this is last year, but we are doing, we will soon.
Have you tried with VGFS?
Yeah, we tried, but I have no numbers because we prepared numbers just
Okay,
a few
no.
days ago, but
Perfect,
we will
yes,
try.
good to know.
Yeah.
Okay, but the application is working well with the,
Yeah.
okay. Thank you. So send me please the slides for
Yeah,
the,
obviously.
okay.